Now we're cooking, it's recording. Okay. I'm going to start with kind of these two at the same time. Are they very similar?
Uh-huh.
SO3 and SO3 -2, but they all have one S and 3 O's, true?
Yes.
Okay. Do you remember from yesterday what I told you to do, like, as far as determining who goes in the middle?
The one by itself.
The one by itself? I mean, that's kind of the easiest rule right now. So, in both of these, which one's going to go in the middle?
Yes.
The S. So, here's what I'm going to do. I'm going to work down here at the bottom because these two are going to be very similar. They're going to end up with different answers, but they're going to be very similar. So, I'm going to start down here with 6 dots because sulfur is in group 6A on the periodic table, so we know that it has 6 valence electrons. And I told you yesterday towards the end of class that you could shorten it by just working off of this central atom. Where should I put my first oxygen? To the right? Do I have to put it there? No, I don't have to, but it definitely is an option. Okay. Where shall I put the next one? Let me go left. Well, that's my only other option so far with what I know. Okay, I put 6 dots around each of the O's of its own color because it's also in group 6A on the periodic table, which means that it has 6 valence electrons too. Now, we have a bit of a dilemma from yesterday, like compared to yesterday's problems. Do I have any more lonely little electrons looking for peace, love, and happiness?
Yes.
Where? On the 2 O's. Okay, well, yesterday we looked at some that had like this, that had like 3 things attached to it. And I told you yesterday that could I go in like a straight line? Like, can I add another oxygen to one of these other oxygens that are over here and just make like a trail of them? No. I told you you have to work off of this S. Like, every single thing has to be attached to this S. Do I need to place one more oxygen? Yeah, because it says O3, and that's not a suggestion. Like, that is a requirement. It has to have a third oxygen. So look, my only options for putting an oxygen on here are up here at the top or down here at the bottom. So watch what I'm going to do. I'm going to do something a little bit different than what we did have done so far. I'm going to put one, here we'll switch colors to a third. For our third oxygen, I'm going to switch to pink. And I did something different with this oxygen than I did with all of the others. Anybody know what it is?
You use the sulfurs at the top, the sulfur atoms, or the sulfur electrons at the
Yeah. Both of the electrons right here in this bond are both black. And but based on my color coding, that means they both belong to sulfur. What's happening with all of my other bonds? What's happening with this one right here? Are they both the same color though? No, I've got one that's black and one that's blue. I've got one electron from each atom. This one's green and one's black. One is from the sulfur and one is from the oxygen. And every other bond that we've made so far, it's one electron from each of the atoms is contributing to the bond. What's different about this one is that both of the electrons in the bond are coming from the same atom instead of one of each. There is a name for this. It is called a coordinate covalent bond. A coordinate covalent. So if you have your notes from yesterday where we were writing out all these things, what should you write as a definition? This is going to be really large since I'm putting my paper in here. When we just say it's where what? If I get you started, both bonding electrons, what? From the same atom. Oops. Both bonding electrons are from the same atom. I wouldn't even mention this, but it's really not possible to draw all these things without doing it. Like, so many of these include this. I'm also going to write this down for you. We're going to have a plan of attack. Like, as we draw these, there's a certain series of steps you need to go through. Your first step should be to make single bonds. And if single bonds doesn't work, then you should try double bonds. And if double bonds doesn't work, then you should try triple bonds. If nothing works, that's going to be my last thing. If nothing works, then you should do coordinate covalent. So if you can't make anything happen without going over 8, you know, if you're going to push something over the 8, which is going to make it angry and grumpy instead of a happy hippie, then coordinate covalent is kind of like my backup plan. When all else fails, we go to it. Bless you. You can play this back later and listen to yourself sneeze. Or you can play it back later and listen to the silence that I often listen to. Can I take this away? Yes? Okay. Hey, we just followed that plan of attack. The first thing we did we make a regular single bond, a traditional one? We made another traditional single bond, and then when nothing else happened, like before this one was on there, if we do our little check, did sulfur have 8? Count up the dots that are around sulfur right now. 1, 2, 3, 4, 5, 6, 7, 8. Does sulfur have 8? So if I make another bond, if I put one of oxygen's lone electrons up there, I'm going to push it up to 9. Like, I cannot make another regular single bond. And y'all, if I can't make a regular single bond, then I can't make a double or a triple bond either. Okay, so we made a coordinate covalent because we had nothing else that we could do. Alright, if we're looking at this one right here, we're going to be done in just a minute. If we do a happiness check and we cover things up like I've shown you before, how many dots does this oxygen have? 7. How many more does it need? 1. This sulfur in the middle, kind of hard to do, ish, right about like that. How many does it have? I'm not counting the one that's up here at the top. 8. It's got 8. Okay, this oxygen over here has 7. It needs 1 more. And the oxygen that's down here at the bottom, as best I could do it, has 8. I have 2 unhappy customers right here. But there's a good news about this one. What does it have? A -2 charge. What does that mean? You know, add 2? Okay, just like we did with our ions, it's going to get 2 from something else. I told you before, there's not like an electron fairy that just walks around and gifts things with extra electrons. It's taking them from something. Who do the anions take from? Cations. So a cation somewhere is giving electrons to this thing. So what we're going to do is I'm going to use a whole nother color. And just like we did with our anions earlier, Yeah. We're going to put those extra ones in there and draw the brackets around it and put its charge and call it done.
It's gotta be a different color though, right?
I chose a different color just to clearly show that they didn't come from any of the oxygens. They came from absolutely nothing that went into that. They stole them from some metal somewhere. The happy hippies took electrons from a big bully. Or became a big bully. I don't know. My world has now been turned upside down. I don't know how that works. Okay. I hear the hunt for colors. Found one, Daisy? You can sharpen them in a minute. Okay, I'm going to go back to this one. I'm going to go back and I'm going to redraw down here at the bottom. You don't have to do anything just yet except watch. I'm going to redraw without the 2 orange dots. Well, I wouldn't do it just yet because it's not going to be right. If you'll just pay attention right now, that'll get you. Okay, I redrew. I took the two orange dots off of it, and I took us back to this point right here. Okay? Alright, I'm going back to this point because this one up here has the same exact formula without the -2 charge. What that means is that all it's going to have is 3 oxygens, the sulfur, and no charge. So, can I, for the top one, for the SO3 up here, can I just simply put in 2 extra dots, slap some brackets around it, and call it done?
No.
Some people are saying yeah, and some people are saying no.
Actually, no.
Why not?
It doesn't have a negative symbol.
Follow the laws, yo. I agree, yo. If there's no charge up there, can I add anything or take anything away? Nope. Okay, so we have a problem with this one, and this one's harder. That's why I chose these 2 to start with. Okay, we followed my rules, right? We followed the plan of attack. We've made singles. Doubles and triples wouldn't work, so we made coordinate covalent. Okay, what do we do when we end up in this situation and I don't have happiness? If the atoms ain't happy, ain't nobody happy.
Sorry for the interruption, but at this time would be Miss Rojo's homeroom and Majeski Moser homeroom to go to room 203 at this time. That's Miss Rojo's homeroom and Majeski Moser homeroom. Please go to room 203.
Okay. Well, I have another suggestion for you that will fix this pretty much every time. Okay? If you are at this point and, like, there is no way. I'm going to mess mine up for a minute, okay? So don't copy me. You good with that? I'm good with messing up my paper. I'm doing this for you. I'll mess my stuff up just for you. Okay, let's just say that I don't know exactly what to do, but I know that crazy teacher lady said something about making double bonds. So I decide to see if I can, like, take this electron right here and throw it into the middle and make some sort of a double bond. So I'm going to redraw this like I've seen some students do it. You are not copying me because you would be copying wrongness. Let's see, the easy one is putting this back at the bottom. I'm going to put the green one back over here to the left. And then somehow I'm going to make me like a double bond here with this oxygen. See what I just did? Okay, is sulfur happy now? How you know it's happy is you count, right? We're looking for 8 unless we see hydrogen, and then we look for 2. So how many has this oxygen got? No, 7. 1, 2, 3, 4, 5, 6, 7. This sulfur's got 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that good? Not bad. Really bad. No, not good. This one has 8, 2, 4, 6, 8. This one has 8, 2, 4, 6, 8. Can I leave it like that? Nope. I cannot. Okay, so let's see if I could do this. Can I fix it this way? I see, right here, I see this single electron and this single electron. Hey, let's just put them together. Let's see what happens if I do that. Let's put these there and there. And we'll make another double bond here. And we'll make, this one was still over here. And the pink one was at the bottom. What you think about them apples? You like my apples? Some people are still studying the apples. Do a happiness check.
Yes.
Well, y'all disagree with each other. We got happy and not happy.
Well, you see, sulfur.
Will you get the door? Or is the door going to get itself? The door got itself.
Yeah, I got my delivery.
Uh-huh.
Oh, yeah.
Yeah, you're going to have to, we'll have to figure out something to do with the chips in a minute. All right.
They say it's not happy.
Not happy? Who's not happy?
Sulfur.
I know y'all ain't happy, but sulfur's not happy? My oxygens are all hunky-dory, but how many sulfur got now? Oh, we didn't make it any better. I actually made it worse. I do have a solution for you. I just want to show you what I see students commonly doing. I'm not leading you down the path of destruction for nothing. Here's my recommendation. When you get to this point, okay, but before you start like trying to manipulate things and move them all around and like make yourself a whole pile of mess, when you reach this point right here and the sulfur, the middle one, becomes happy, do not keep drawing things. If sulfur's happy but the other things aren't, what you need to do is you need to redo your sulfur. Go back to its original sulfurness, like this. Got that? Okay, and we're going to try to make 2 coordinate covalent bonds this time instead of 1. Are you following what I'm proposing? Instead of putting 2 oxygens, like one here and one here, I'm proposing that we use up these coordinate covalents first. Like, I'm going to put 1 oxygen right here like that. I'm going to put another oxygen right here like that. I have no choice but to put a 3rd oxygen over here with one of the empty electrons. Is that true? Okay. And if you're taking this all in, I'm like, this is different. It does present me with different circumstances. Over here, the sulfur was completely happy. It had 8. But over here, and neither one of them are finished, over here, sulfur doesn't have 8. It's not happy yet. It's got 2, 4, 6, 7. And this one has 7. I still have 2 unhappy elements in both of them, but I can work with this one. Anybody have a solution for me? I mean, I'll wait and see what you can think up to fix this. Sulfur needs 1 more, and this oxygen needs 1 more.
Which oxygen?
This one, there's an empty space right there. So this one needs 1 more, and this one needs 1 more.
Put them in the middle?
What do you want me to do? Right here? Like these 2? Well, I can't take this one and just put it over here, can I? Can I just move this electron over? Do what? So you want me to throw the 2 in the middle? Or what? No. Well, you're saying them. I don't honestly know if you're talking about like the green dots, the black dots, the actual O. Huh? Take the blue ones and do what with them? Say it again. There were a lot of thems in there. I didn't follow.
That blue one right there,
Yeah?
you can leave it, but the other one put on the other side, and then move the 2 on top, and then the 2 on the bottom, more to the right here.
Kind of catty corner.
Yeah,
What do you want me to do with this one?
put on this one.
Put it on the inside? Okay. If I take this one right here and this one right here, and we put those together in the middle, what does that make? I heard somebody say it. Somebody said it. How many shared pair would be in the middle if I put these two in there as well? They're already sharing one pair.
You could put them in the middle.
Yeah, but what does that make if I put them in the middle? A double bond. Makes a double bond. Okay, so I'm going to redraw it up here where there's our actual answer space. So here's what we're proposing. We're proposing moving this one, so I'm just going to redraw the top one exactly like it is. And then I'm going to redraw the bottom one exactly like it is, and then I'll move things around. Okay. Well, I already had one black dot there, and we're proposing moving the other one around, so I'll move it over. And we already had one blue dot in the middle, and you're proposing moving this one over, so I'll put it in the middle as well. And then CJ said correctly to make the extra unshared pairs that are on the O become kind of catty corner in order to make them fit. Alright. Do a happiness check. You have to check every element, all three O's and the S. What is their state of happiness? All of them?
Yeah. Yeah, all of them would have that.
They all have 8? Yep.
I told you from the very beginning to put them in the middle of the system.
I know, but not everybody's going to get that. I see people do some crazy stuff sometimes with these drawings. What I see a lot of times is people don't do happiness checks. So when they're finished, I go over and I look at their drawings and they've got like 12 dots around the center atom, and that's a no-no. Like 8 is your limit here, and hydrogen your limit's 2. Okay, I picked like the hardest situations here, you know? I mean, like this is really the most difficult situation, and it's what will cause most people grief, if any. Okay? I have some other ones on here, and what I'm going to do is give you a chance to draw them. You need to use my plan of attack. And we can kind of amend the plan of attack if you would like to, if this helps you later. What we had here from earlier was the plan of attack was to make single bonds, and then if single bonds didn't fix it, you go to double bonds, and if double bonds doesn't fix, you go to triple. At any point, if you're going to push it over 8, you can consider coordinate covalent. So I guess we could add like, you know, a second star and say, if you are stuck completely, take atoms off the outside and redraw making more than one coordinate covalent bond. Like our example there where we took stuff off and we just kind of abandoned the plan. I put this as your plan of attack because y'all, most of the time that's not going to fail you. For the most part, that should serve you well. If you don't get the coordinate covalent thing, like, you still need to get single, double, triple, but you ultimately need to get coordinate covalent as well. What I want you to do now for maybe the next 10 or 15 minutes is start up here at the top and practice drawing. See where you get.